Well, we've got Lynn talking about communities, rural economies, and diet in Bronze Age and Iron Age Greece. Probably can let her introduce this, but I think this is an important talk for me at least because she's the one that got me into this subject. So I hope you will enjoy this as much as I probably will. So I'll let her start.
Great, thank you very much. Are you? Yeah, there we are. Okay, well, in that case, I'll do it this way. Get very organized. That should do it. Okay, well, where are your arrow keys? Dun, 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 dun. There they are. Got them. Right. Okay, well, thank you very much. Thank you for inviting me to come and talk to you. And I think it's brilliant that as many of you did showed up at what is a desperately busy time of year for everybody. So real dedication, and good to see that kind of dedication to budding archaeologists. So what I'm going to talk about today is the period between the late Bronze Age and the Iron Age in I see the problem right there. That looks good. The late Bronze Age and the Iron Age in the Aegean. And this was a really exciting period in many ways because it's really one of transformative change when the Bronze Age palace societies crumble over a period of about a century and new, more localized communities with different forms of governance kind of rise and take over. So what I want to explore today are a whole bunch of issues that span the late Bronze Age and the Iron Age related to land use, agriculture, and diet. And these are important because changes in these domains have been used as evidence to explain changes in Aegean socio-political organization across this period. So I'll start with the health warning and two things that I won't talk about. Or at least not very much. And the first is really the question of why late Bronze Age societies actually collapsed. This is a hugely intriguing and very important question. And it's so big and so complicated that I could not deal with it here. And it's not really relevant. And there are other people who've dealt with it better. There's a very good article in American Journal of Archaeology by Bernard Knapp and Sturt Manning about this. There is a bibliography for this lecture, which Ethan has a copy of. So if anybody wants a copy of it and to follow up on any references I give, that's your man. Or you can just email me and I'll send it to you. And somebody called Guy Middleton and lots of other people have already written about this and addressed it. So we're not going to talk about why the collapse happened. And the second thing we're only going to talk about a little bit is the role of climate change in the development and the changes in polities and communities that took place in the late Bronze Age and early Iron Age. And this is important. A particular focus of discussion has been something that is called the 3.2 KYA-BP climatic event, KYA meaning 1,000 years ago, and BP before present. This is roughly a wetter period in the earlier part of the late Bronze Age, followed by a more volatile and drier conditions in the later part of the late Bronze Age, around 1250, 1200 BCE, across the Mediterranean, lasting about 300 years. Now, this phenomenon, the 3.2 KYA BP event, has largely been identified using palynological data, that is pollen data, from coring in combination with geoarchaeological analysis and C14 dating. And this produces useful but quite coarse-grained, low-resolution data sets that you can't really stick onto historical or archaeological data sets. And again, Knapp and Manning have discussed this in some detail. We'll mention it briefly, but only briefly. Now, the production of food is obviously central to the social and political organization of communities. And concomitantly, social and political organization have often been associated by scholars with specific kinds of diet and practices of food production. And that's certainly the case for this Bronze Age to Iron Age transition in the Aegean. And traditional scholarly accounts of this period have largely been driven by textual sources, including on this topic, until relatively recently, since other kinds of evidence have in the past been more limited. So I'm going to start with landscape and material cultural evidence, deploying archaeological, environmental, and bioarchaeological data, especially stable isotope analysis, to address these larger archaeological and historical questions about lifeways and diets, which directly relate to agrarian practice and land use. So basically, I will start with the canonical narrative. Now, any of you who've studied anything to do with the Aegean at this point, and being Oxford, I expect some of you have, yes, are probably aware that with variations, the canonical position on what happens in that transition from Bronze Age to Iron Age is that of Anthony Snodgrass, who identified an 8th century emergence of the city-state polis. And it identifies large-scale changes in population and land use as a major causal factor in this transition. The classic book is his Archaic Greece, the Age of Experiment, written in 1980, which was at the time a game changer, though it's now obviously outdated. And he presented this period as a rapid and concentrated structural revolution, which, as he said, and I quote here, set up the forms of state that were to determine Greek political history. And his core argument was basically that there's this drastic population drop at the end of the Bronze Age, leading to the underuse of land and pastoral economy, hence all those meat-eating heroes that you meet in Homeric epic, and suggested that in the 8th century, the population rose sevenfold, though lots of people have questioned this as unrealistic, and I think it is unrealistic. And he believed that there was then a switch to our arable agriculture, a reconfiguration of settlement based on it politically unified independent settlements with attractive land surrounding them, with no distinction between the inhabitants of the settlement and the rural territory, though basically the Greek city-state. And then, of course, a key consequence of this in his imaginary reconstruction was a shortage of land due to overpopulation, to which colonization was one response. Now, this is an argument that was based almost entirely on datable burials and the numbers of then known sites. And basically, datable burials means burials with fineware pottery, since excavations of those sites often left much to be desired by modern standards. And Ian Morris from 1989 produced a modified version of this in his book Burial and Society. And again, using the same body of evidence, but importantly, he pointed out that burial customs as well as burial numbers changed over the period 1100 to 700 BCE in ways that suggested not everybody was entitled to formal burial. And this is clearly quite right. And he suggested that population doubled in the 8th century. I think that's still probably unrealistic after a post-Bronze Age decline. Now, specialists in researchers of these periods, people like Sarah Murray, James Whitley, Guy Middleton, are already finding this narrative quite inadequate. And it's being chipped away at, but it's so deeply embedded that this is what everybody gets in their first year Aegean archaeology. Yes, I see nods. This is the narrative that you get in your first year Aegean archaeology lectures everywhere. And from my point of view, this is just completely and utterly wrong. It's very problematic. And there are lots of people who are still writing this stuff. I just give you a couple of examples here with, McInerney or Josh Ober's particularly terrible book on the rise and fall of classical Greece, or Sarah Murray's even quite sensible discussion, but where she is still saying that when labor is hard to come by and land plentiful, it might make sense for families to invest more time and resources in herding, which requires less per capita input of labor than agriculture. This is written in 2017, and it is so wrong that it pains me. It's really just not good. And there are lots of other examples one could cite, but I won't. Now, moving rapidly on to settlements and landscapes. Now, the archaeological evidence for settlement and land use over this period is very patchy. Surprise. And for the late Bronze Age, major palatial and settlement centers are generally very well investigated, though in most areas, the evidence for smaller sites and rural land use are better documented in some areas than others. And in the post-palatial period, what's called LH3C, late Hellenic 3C, and during most of the Iron Age, with some exceptions, settlement sites are less well known, and lots of our evidence is based on graves. Now, from about 1150 to 1100 BCE, and through the 10th and 9th centuries, there are certainly many fewer known sites, and these are, not surprisingly, a lot smaller than the Bronze Age sites. Some, like, is this what we want? Yes, some, like Nicoria, which is the slide that's up there now, seem to show a gap in occupation, although the gap is pretty short and not as long as the original excavators thought. There's no evidence of post-palatial LH3C pottery at the settlement site of Nicoria, but there's lots of evidence of post-palatial material culture, including the presence of an elite group in nearby tombs, as well as tombs more widely across Messenia. And the reoccupation of the site starts around 1050 and goes down to the end of the 8th century. Now, there may well have been fewer people, and I'm sure there probably were fewer people, but more importantly, the demise of palace rulers driving both the intensive and extensive cultivation of agricultural land means that agricultural practices, meant that agricultural practices may have changed as demands from palatial and local elites vanished or altered. I'm sure less land was being exploited, though not necessarily less intensively cultivated in some parts of the landscape. And I'm sure that some land was differently exploited than it was in the Bronze Age. So the archaeological pattern is potentially consistent with a drop in population, but even more clearly, it indicates an economic decline, which means that fewer imperishable artifacts make it to the archaeological record just because people have less stuff. So archaeologists' estimates of land, the extent of land under cultivation, have largely depended on what is, in my view, a very flawed methodology to estimate the amount of land area cultivated in specific periods. So recent work by Alex Knodel, this is 2021, so it's very recent, consists basically of drawing a circle around known sites and assuming this was the area exploited for agriculture. And Erica Viberg, Martin Finet, and their colleagues similarly estimated in a 2021 article consolidated territorial extent for sites of different periods identified in archaeological survey, again, as a basis for estimating land under cultivation and land use. But these are very inaccurate and unreliable proxies. It's a terrible way to do it, and this is why. In the fragmented rural landscapes, and even at the best of times, volatile and unpredictable climates and weather patterns of Greece and much of the Mediterranean, farming just does not work like this. It's not like you have a chunk of land around your city and you only cultivate the bit right around it. Instead, households and communities tend to exploit a range of microenvironments at different altitudes and with different soils, degrees of slope, aspect, and so forth, some of which are very far distant from the main settlement. And this is part of a set of resilience strategies which can be demonstrated to have been built into Mediterranean farming practices for many millennia. So, for example, if you plant cereals in both warmer, drier, and lower areas, as well as cooler, wetter, higher ones, your chances of getting a decent crop increase, and farming becomes somewhat more reliable and predictable, whatever the weather that year. You might even plant different kinds of cereals or different cereal crops in different areas to take advantage of different very local conditions in terms of moisture, soil types, exposures, all sorts of things. And so consequently, the amount of land exploited by any particular community or settlement is probably not easily estimated because it's fragmented, not consolidated. And depending on factors like weather conditions, the amount of land cultivated in any one year and where it's located may be quite variable. And that doesn't even take into account areas of the landscape exploited for grazing, fuel, and other kinds of resources. So, moreover, the implementation of these resilience practices would have been even more important for maintaining the stability of production in that Bronze Age to Iron Age transition if the impact of the 3.2 KYA BP hypothesis of greater climate fluctuation and volatility over that 300 years around 1200 is correct. The analysis of speleothems, these are basically stalagmites in caves in the Peloponnese, there's really good work done by Martin Finney and Eric Weiberg on this, produce higher resolution data, which suggests that climate volatility in post-glacial period and early Iron Age really did happen. So it wasn't that it got wetter or drier, it just got more unpredictable, if that makes sense. And that's where exactly these kinds of resilience strategies, where you use all different bits of the landscape, would be critically important. And also, in periods of material poverty, most of these agrarian practices would leave no archaeologically discernible traces in the landscape. So archaeological and linear B evidence suggests that practices such as keeping large numbers of folded livestock, that is livestock, back at the ranch, as it were, and the concomitant manuring of fields would have been much more characteristic of late Bronze Age palace economies, in combination with higher levels of consumption by at least some sectors of the population. They would also have been much more likely to leave more trace in the wider landscape because of things like manuring and the sherd material that gets mixed up with the trash that goes out on the fields. As a higher proportion of late Bronze Age off-site sherds found in surveys, surveys in lots of different places, Boeotia, Messenia, all sorts of areas, indicates. So relative material poverty with lower levels of consumption, household-based agricultural exploitation, and lower levels of livestock keeping, on the other hand, which are probably more characteristic of the post-glacial periods, 3C and immediate afterward in the Iron Age, are far less likely to leave archaeological traces in the landscape. So as a proxy for population levels and levels of agricultural exploitation, estimates of the block territory in the immediate proximity of sites is totally unreliable. Now, survey data for many areas of Greece, in fact, and I'll whip through this, suggest that even by the end of the 8th century, in most areas, the countrysides are comparatively empty, in contrast with later periods. On the whole, communities occupied nucleated settlements focused on the best agricultural land, even though they clearly made use of the wider landscape. So that was, where are we? Go back one. So that is Pylos, southwest Messenia, where there'd been Pylos and lots of palaces, really goes down in the Iron Age. The same is true in Chaia, and you can see that even in the 8th century, it's still very empty. And the same is true. This is Thespiae, important city in classical times in Boeotia, but barely a hamlet in the late Hellenic period or the Iron Age. There is just much less Iron Age material. The most successful of these settlements, like Thespiae, of course, later became urban centers, and Iron Age levels are less rich in material remains, so are Bronze Age levels at Thespiae, partly because they just get buried by all the classical junk that ends up on top of them. On the whole, rural settlement doesn't really expand until at the earliest, the later 6th century, the sort of second half of the 6th century. So Nodell's suggestion that the 8th century BCE had a crowded countryside based on all that circle drawing is just plain wrong. Now, another important source is obviously the archaeobotanical material. And I know it's a bit of an eye-boggling chart, but it does give us direct evidence of the kind of stuff that people are eating. And this is just a range of sites across the late Bronze Age, early Iron Age. And what it basically shows is that the general range of plants and animals that people exploited across the period are in fact pretty much exactly the same in terms of things like sheep and goats and other animals. It's sheep, goats, pigs, cattle, all documented right across the period, along with small numbers of equids. Not so much fish, but it's hard to find fish bones sometimes because they disappear and they're very small, and people don't always see them. And if you look at the range of plants, again, barley, various kinds of wheat, but millet in northern Greece, this becomes important in a few minutes, a range of legumes, tree crops, olives, vines, fig, almond, all of these things are common right across the entire period. Now, moving swiftly on, and I'll skip most of this bit because, well, I mean, I'll just leave it up there for a minute. You guys have all know what stable isotope analysis is? Yes, I assumed you do. Great. Okay, so you know how stable isotope analysis works. And what I've done, and what I'm going to talk about for the rest of this talk, is basically what I've done is to look at the stable isotope analysis that's been done on a whole range of sites right across the Aegean, from the late Bronze Age down through the end of the 8th century and into the Archaic period. And obviously, it's a very crude comparison in lots of ways. I've focused on the dietary isotopes, so carbon and nitrogen isotopes. And the reason for that is that for other kinds of data, like strontium and oxygen, where you can look at things like mobility, there isn't so much evidence on that. There is a lot of evidence. There is a lot of evidence on diet and on the dietary sort of isotopes, and that is really interesting. And they really can tell you something interesting about the differences and inequalities between different people's diets in this community. Now, I've specifically only looked at older adolescents and adults, because the minute you start incorporating young children into the data, it completely skews the figures, because breastfeeding has such a big impact on infants, and they end up with just totally different nitrogen carbon balances, which is not entirely surprising. And what is very interesting is that right across the period, although these are small data sets, you can do some interesting things with them. Right across the period, the sort of rough composition of people's diets remains very, very broadly similar. You do get some really interesting things from different isotopic signatures, where people are ingesting more C3 and C4 protein. I will see C4 and C3 plants, which I'll come to in the end, and fish, but that's kind of another story, and we can talk about that in a few minutes. So that is my combined isotope chart. for the late Bronze Age, early Iron Age. Now, it's over a long time period. It includes sites from different parts of Greece and different environments. So you get a widely spread bit, but within 2 standard deviations, which is the circle in the middle, you can see that you've basically got a nice cluster there, which is not wildly different. And speaking to my stable isotope colleagues, they say that where the range of difference is around 1 mil, diets of individuals can be considered generally similar. And for the Bronze Age and Iron Age data set, you get a variation for D13C, for the carbon isotopes, of around 1.22 mil. So that's pretty close. Where you get an interesting difference is actually in the D15 nitrogen values, where you get a range of about 6.2 to 10.4. That is about 3.8 mil. And that is actually quite significant and suggests that even within that main cluster, what really differentiated individuals' diets was the consumption of desirable high status foods, especially meat and dairy products. What a surprise. And so it appears that in those D15N values, wealth, status, and inequality are genuinely clearly manifest and expressed in diet right across all historical periods. And that is quite cool. Now, obviously, on the basis of archaeological and material cultural evidence, elite groups, we're on the right slide. Okay, so yes, you can see the differences there in the figures. Okay, sorry, I was 1 slide behind. So, one of the things that is very interesting is that on the basis of archaeological and material cultural evidence, elite groups are documented in all periods throughout the Bronze Age and the Iron Age. And in the isotopic data, outlier individuals and groups with these elevated nitrogen levels, that is D15N values ranging from just below 10 to around 11, probably had diets that were higher in meat and dairy. And the archaeological and faunal evidence suggests that, especially in feasting contexts, as well as the very limited textual evidence that's available, identifies the consumption of large amounts of meat and dairy as key social indicators of elite status. We know that. And such elite groups are most evident in the data sets from Mycenae. That's the red dot up on the top. Let's see if we can get our little laser pointer here. Where are we? Okay, so now are you going to give me a laser pointer? Yes, you are. Okay, so this up here, those people in the red dots are from the Schaff grades at Mycenae. And you can see really elevated nitrogen, you know, big meat eating. And the other group are the purple ones in here who spill over above that 18 figure. They're from the palace at Champsaur in the same period. So in that sense, the isotopic data is kind of bearing out exactly, you know, telling us kind of what we knew already, that these people are rich and elite and they have rather nicer diets. What is really interesting with particularly with these guys over here in the purple dots and Fred up here, these people, is that they in particular fall into a range where you have these high nitrogen levels, but you also have very peculiar carbon isotope levels. And that is because these people were either eating more C4 plants, which is very unlikely because the only C4 crop plant that you get growing in Greece is millet. And I'll talk about that in a few minutes. You get that very regionally, specifically in places like Macedonia. Or more likely in this case, they're eating lots of marine fish. And indeed, Naftalioti, the person who did the isotope analysis of the source material, suggests indeed that this was fish eating rather than something like millet. And the idea that fish, and especially big fish, are a very high status food, is something that is really deep seated in the Aegean, and it goes on for a really long time. So much later in the classical and Hellenistic period, you can actually see again, and this is a period where we have much more textual evidence, obviously, and iconographic evidence. You get these fish plates with like big fish on them. You know, look what I am eating, and it's very high status. And they also, there's a lot in the literature about this, and it's very clear that you get these outliers who are eating much higher levels of marine fish than other people. And we know that that's the case in this later period. What's a surprise is that kind of cultural valuing of large marine fish goes quite so far back in the Bronze Age, because I don't think we knew that before. And that turns out to be quite interesting. So if we, right slide, yes. Okay, so if we focus on the Bronze Age data alone, it becomes also obvious that individuals are randomly scattered through that main cluster from all periods, from the Middle Bronze Age to the post-Palatial LH3C period. Now, the square markers on this slide represent smaller communities at LH3C sites, that is post-Palatial. So after the palaces are already gone. And their distribution suggests that the demise of palatial political and administrative structures makes no difference at all to these communities' diets or their nutritional quality at this time. And the differences that we do see are much more related to regional factors. So if you look at sites like Magires and Portes in Elis, in Elis and Ischia, which are little square sites on there. Portes is the yellow one, and Magires is the kind of magenta one. You can see that these are both similar to other Peloponnesian sites like Lerna and Mycenae, and fall right in the main cluster. And you also get some people in these other sites. What am I not seeing? You also get some people way off on the end in some of these areas who have these very odd diets, and again suggesting either marine fish or eating lots of millet. Right. Now, if we move to, where are we? Here, I've got 3 Iron Age sites represented in square markers. And most individuals, again, fall within the main cluster. A few show higher values, but what it looks like from the overall kind of set of data is that most individuals, if anything, consume in the Iron Age smaller amounts of meat and dairy in the Bronze Age, even among the elites. And if we look just at the Iron Age data, okay, you can see that a very small number of people here from Halos, which is a coastal site in Thessaly, and a larger number from a site called Agras in Macedonia. Agras is the yellow ones, and Halos is the blue, show up in this area where you've got, you know, marine, what you would think would be marine fish, but in this particular case, the Halos people on the coast probably are actually eating fish. the Ugras people are almost certainly eating millet. And that's because millet is in this period really pretty much restricted to Macedonia. What is also very interesting in this burial population is that you have practically no individuals that look like they have really terrible diets. So that is almost certainly because the majority of the archaeologically detectable and datable burials that we have from the Bronze Age and the Iron Age are, surprise, wealthier and higher status groups. So we are not looking at the full socioeconomic range of people in this period. And again, this is something that in the traditional accounts, I don't think anybody really properly took account of. But the dietary data make that really pretty obvious that we are likely to be missing the poorest social groups, which is also very interesting. So for all the limitations of this data set, the analysis of the stable isotope data reveals some really interesting patterns about diet and consumption in the Bronze Age and Iron Age and how it might or might not change across that period. So within that main cluster, the difference between Bronze Age and Iron Age dietary consumption is not statistically significant in terms of the range of different qualities of diet. And I tried that, I tested it. Statistically, there is no statistical difference from site to site or whatever. The data cover roughly the same spectrum in both periods, although individuals' diets vary and some are clearly different or better than others. Overall, diets in these communities are largely C3 plant-based, that is, people eating mostly wheat, barley, fruit, nuts, vegetables, Mediterranean diet, with a significant and varying proportion of meat and dairy products. The range of crops and plants and food animals is confirmed by the archaeobotanical and the faunal record, and the archaeozoological record, including stable isotope analysis of animal bones, suggests that livestock rearing, mostly sheep, goats, and pigs, was integrated with agrarian regimes on a pretty small scale. Across the total sample, the diet of those individuals from Agras in Iron Age Macedonia is significantly different because it probably included a major C4 plant component, millet, as well as freshwater fish. However, across the total sample, the difference in the range of D15N levels between the Bronze Age and Iron Ages is statistically insignificant. And this could be, again, as I've just said, because the burial population is just wealthier people, not the entire spectrum. And we don't have people with truly terrible diets. But what is clear is that the foods that communities were growing and eating, as well as the consumption values and habits, really doesn't change across this long period. Outlying groups and individuals are discernible in both periods, demonstrating extra elite habits of higher consumption of meat and dairy and marine fish. And while elite habits of the consumption of both food and material goods are manifest in funerary contexts in both periods, in both of these periods, it's often very difficult to associate human bones with specific assemblages of grave goods in tombs that contain multiple individuals, particularly in the late Bronze Age, but also in some areas in the Iron Age. A lot of the tombs are these kind of communal tombs of various sorts, solace tombs or chamber tombs or various other things. And because they're constantly being reused and more people put into them, everything gets kind of stirred around and mixed up. So it's really difficult to say that skeleton there belongs with those bits of material stuff unless it's very, very closely associated. And this is where the dietary analysis is actually quite interesting. And also why elite consumption doesn't always appear to map directly on to rich graves because of the complex archaeological context, taphonomy, and the burial customs that you have. It's actually very complicated. So while context of meat consumption were surely in part associated with feasting and banqueting, the meat-eating heroes of Homeric epic cannot possibly be interpreted, as many people have suggested, as reflecting any actual post-Bronze Age or Bronze Age pastoral society. What epic poetry does suggest, however, is the desirability of meat consumption, evident in all periods. References to large flocks and abundant meat reflect the aspirations of poets and their audiences, not the realities of life for most people. Nonetheless, there were still elite individuals in these Iron Age communities who were privileged to consume greater quantities of meat, dairy products, fish, and seafood than other people. So there is still a social hierarchy there and a political hierarchy. These dietary markers of elite consumption are manifest from at least the Middle Bronze Age through Roman times and must signal wealth and status hierarchies. And they're certainly there in the Iron Age. This is not an egalitarian society. However, there are certainly fewer archaeologically visible and datable graves in the final phases of the Bronze Age and the Iron Age. This could simply be part of a larger pattern of a lower level of productive activity with a lower material footprint than in earlier or later periods. Certainly the Iron Age human footprint on Greek landscapes is much fainter and archaeologically less discernible in many places until well into the 6th century BCE. But if this is the case and communities were simply smaller and poorer, it's interesting and very important that diets and the expression of eliteness through food consumption appears to have changed so little. Thank you very much.
Do you have time for some questions?
Absolutely.
I have one. What do you använder bilder ritningar skulle influence C4 other than fish and billet?
Yes, there is something else that can influence it. And I didn't really talk about it, although it's very interesting. And that is when you have animals that are consuming C4 plants and the animals are then being eaten by people further up the food chain. So for example, again, in some places, and this may be the case in a place like Halos as well, and certainly in some other places near the coasts in the Aegean, that one really important grazing resource for animals is often places like salt marshes. And salt marshes have lots of halophytic, that is to say, salt-friendly halophytic plants in them. And lots of those halophytic plants are actually C4 plants, not C3 plants. And this is even more cool. There are some really good studies of animal. Normally what you do when you do it, and you guys probably know this, but normally what you do when you're doing human isotopic analysis is you calibrate it against the animal bone analysis as well, because that gives you a kind of baseline, because people eat the animals and therefore the isotopes reflect to some extent what people are eating. But in some areas where they've done really high resolution faunal analysis with isotopes, and particularly using laser ablation on teeth, where you can be peeling off little layers of dentine, you can actually get data which shows you where animals are being grazed from year to year in different areas. So some years or some periods they're eating more halophytic plants and more C4 plants, and other areas they're eating different plant mixes and things like that. And you can pick that up in the analysis, which is super cool. So it gives you an indication of how people are managing herds and the way in which those herds are being moved around really quite a big landscape. And also the way people are keeping them. So you can distinguish things like range sheep and range goats from, say, somebody's house goat or house sheep, because they're eating different stuff. It's super cool. And you can really put together quite a high resolution picture out of that. So yes, there is an exception, and that's it.